All right, so this video is going to go over pages 5 through 7 in your vectors packet. So we're going to go over directions on this page. So how to name an angle's direction. Okay, so when you're looking like in a quadrant, so say like you're looking at the north of east or northeast quadrant. Okay, you've got to pay attention to one. You can look at it logically of, let's look at this bottom one right here, is if I am starting east and going north of it, okay, that's why it's called north of east. Now, the trick that I teach is whatever the last letter is, that's the actual cardinal direction the angle is touching. So you see how it's touching east here, and then it starts going north of it. Okay, so that's why it's north of east. Now, vice versa is if the last letter is in here, it's touching the north line and then going east of the north line. So you can do that for any of them. Like if I did south of west, okay, so west would be my last letter. So that means it's touching the west line and then going towards the south line. So south of west. So that's how you do that trick. Regardless is whenever you have these two angles, okay, these two angles make up a 90-degree angle. So if I give you one of them, we know that both of these should add up to 90 degrees. So if I give you one and ask you to solve for the other, all you got to do is subtract from 90 degrees, and that will give you the other angle. So we're going to do some practice. So draw and label 30 degrees north of west. So we're going to deal with north, and we're going to deal with west. Okay, now you do not have to draw an accurate 30-degree angle. You do not need to break out a protractor and make it truly 30 degrees. I always just throw a line down the middle. Okay, one, that just gives you more room to work with when you're writing stuff. And it's just easier. You're still solving stuff the same and stuff, so it doesn't have to be perfectly accurate. So you do not need to try to waste time making it 30 degrees. Now, 30 degrees north of west. So I look at that last letter. So west, that means it's touching the west line and it starts to go north of it. So my angle is right there. So this would be 30 degrees. Now when it says draw and label a direction that's equivalent, that just means we're going to draw the counter angle. So that basically means is we know the bottom angle is 30 degrees. So now we want to know what would this angle be. So this would be 60 degrees because both those should add up to 90. So that would be 60 degrees and it's touching the north line. Okay, so that would be west of north. Okay, so let's do some more practice. Draw and label 15 degrees south of east. Okay, so we're dealing with south, we're dealing with east. Okay, so we're in this bottom right quadrant, so I'm just going to draw a line. Now it says south of east, so east is my last letter, so that means it's touching the east line and then going south. So this would be 15 degrees south of east. So we're going to draw our counter angle. Okay, so I'm going to draw my line down here. So we know this angle has to be here, so 90 minus 15 would give me 75 degrees. So this would be 75 degrees. It's touching the south line and going east of it, so it would be east of south. Let's do another one. Draw and label 50 degrees west of south. So we're dealing with west and south. So I'm just going to draw a line down that quadrant. Okay, so south is your last letter, so it's touching the south and going west of it. So this is 50 degrees west of south. So if I want to draw the counter angle, 90 minus 50 gives me 40 degrees. Okay, and this is going to be 40 degrees. It's touching the west line, so that's going to be your last letter. So it would be south of west. Okay, so now let's actually do a little bit more practices of that. We're going to kind of put it all together with direction, do our Pythagorean theorem, and our SOHCAHTOA stuff. So find the displacement of an airplane that flies 500 kilometers due south and then 700 kilometers due west. Okay, so what we're going to do is there are 3 steps we're going to do. Is one, we're going to draw the diagram. Okay, so we're actually going to show what it looks like. 2 is we're going to find the resultant. Okay, that's a fancy word for hypotenuse. And then 3, we're going to find the angle. Okay, so that little circle with a line through it, that is just means theta. That is just the Greek symbol, okay, that we're going to use for angle. So I am going to draw my quadrant. Okay, so I got north, east, south, and west. Okay, so it does not matter which direction you go first. You can go south first, you can go west first. It doesn't matter. Your angles will be different, okay, but I'll accept both angles. So I usually just go off what they tell me first. So it says it flew 500 kilometers due south first. So that means I'm just going to go south first. So let me switch my colors up. So I am going to go south first. So for 500 kilometers. And then from there, so again, don't go back to the center and then go west. Okay, you technically don't even have to lift your pen from the paper. You just want to go directly west from the end of that last arrow that you drew. Okay, so this will be 700 kilometers due west. And then it will always tie back in. Okay, so your triangle would look like that. So that means we are looking for our angle right here, and we're looking for our resultant right here. Okay, so that would be how you actually draw it. Okay, so now what we're going to do is we're going to find, we've already done step one. Okay, now we're going to do is we're going to find the resultant. So I know two sides of a right triangle if I do Pythagorean theorem. So a squared plus b squared equals c squared. Okay, so r would be like your c. Okay, so that's your hypotenuse. So whenever we do this, in order to make c squared just c, you have to square root both sides. So that means we're going to square root whatever a squared plus b squared is. So 500 squared plus 700 squared. Okay, and we're going to square root that whole thing. And that's going to give us a resultant of 860.23 kilometers. Okay, now that is just my displacement or my resultant. That basically just means that if I flew 500 meters south and 700 kilometers west, okay, this line right here, this dotted line is just 860.23 kilometers from where I started. Okay, so now what we're going to do is it's not enough just to tell me that. You've got to actually tell me the angle or the direction it went. So think about this as like you're trying to, say you try to repeat the same process and end up at the same spot. If I just told you, hey, go southwest, okay, there's a lot of room in southwest. Okay, I want to know what is the specific angle that you took to get there. Okay, so this is where you got to know your SOHCAHTOA stuff. So sine, and we'll give you these. So sine of your angle equals opposite over hypotenuse. Okay, cosine of your angle equals adjacent over hypotenuse. And then tangent of your angle equals opposite over adjacent. And we'll give you those. So when I'm labeling a triangle, okay, 500 kilometers is right next to my angle. That is called your adjacent. Okay, it's right next to your angle. Adjacent just means next to. 700 kilometers would be your opposite because it's opposite of your angle. And the resultant we just found was the hypotenuse. Okay, so now what we're doing is we're trying to find an angle. And if you noticed, all of these have angles. Okay, so technically, now that we know the hypotenuse, you could use any one of these you want and find the angle. But usually my rule of thumb is I like to stick with what they gave me in the original problem, so the 500 and 700, okay? Because if I messed up in the first part where I found the hypotenuse and I try to take that over into the next step, that kind of creates that domino effect. So I'm going to stick with adjacent and opposite. So I would look at which one of these three has opposite and adjacent. Well, that's your tangent function. Okay, so tangent of your angle, so I don't know my angle, so I'm going to leave it as theta, equals opposite, which would be 700, over adjacent, which is 500. Now, I've got to get this tangent off of this angle. I've got to move it over to this other side. And when you do, okay, so your angle becomes the inverse tangent, so it looks like tangent with a little -1 exponent, of 700 divided by 500. Okay, so a couple things here is if you want to do inverse tangent in your calculator, just press second tangent and it will do it for you. Second thing is you have to make sure you're not in radian mode. You got to be in degree mode. Okay, so just make sure that's highlighted. If you need help with that, let us know and we can help you convert to that mode. So if I type that in the calculator, I am going to get an angle of 54.46 degrees. Now, if you look, it's touching the south line. Okay, so that's my last letter, so that's going to be west of south. Now, I'll accept two angles for this answer, that one or it's counter angle. So that means that you went west first and then south. You're not wrong. Your angle would just be different. It would be 35.54 degrees south. Let me go back on that one. South of west. So I would accept either one of those angles. It just depends on which way you went first. Okay, regardless, those both add up to 90 degrees. Okay, and that'll end this one.